Thank you for joining. My name is Mike Friesenegger. I'm with SUSE. I'm part of our Hardware Alliances organization, focused on working closely with Cisco. And today, for this session, we're going to be talking about SUSE OpenStack Cloud and the work we've done with Cisco to integrate SUSE OpenStack Cloud with Cisco's ACI, Application Centric Infrastructure. To talk about Cisco, we've actually invited Mike Cohen, who is the product manager, senior director of product management, Cisco systems for Cisco Nexus 9K and Cisco ACI. So hopefully I've done an okay job of introduction. Mike's going to be talking and kind of introducing what Cisco does around software-defined networking with their ACI capabilities, their Nexus 9K. But before we let Mike go off and talk a little bit about that, I just want to run through the agenda and focus on a number of things. So today, the goals of our session, I'll cover that here in just a moment. Mike's going to talk about driving innovation, the path to agility in an app-centric world. Again, software-defined infrastructure, including software-defined networking. Mike's going to cover what Cisco ACI is all about and what Cisco's doing with regards to OpenStack upstream. And then I'll pick it up and talk specifically about what SUSE and Cisco have been doing to enable and make it easy for customers to deploy SUSE OpenStack Cloud and integrate it into a Cisco ACI environment. And then no SUSECON session would be a great session. I'm already setting the stage. This is going to be an awesome session without an awesome demonstration. So you're going to actually get to see SUSE OpenStack Cloud and the integration work that we've done with Cisco ACI. So hopefully it won't get too technical, but I want to make it somewhat technical because this is a technical audience. So we're excited to have you here. So quickly, the goals of our session, very simple, 2 goals. Introduce the Cisco approach to software-defined networking in an OpenStack world. Mike's going to take care of that. And then I want to highlight the integration between SUSE OpenStack Cloud and Cisco ACI. Easy, right? Simple goals. So this is not a 101 session for SUSE OpenStack Cloud. If you're looking for that type of session, there are a lot of other sessions. Can anybody tell me how many sessions here at SUSECON are dedicated to just OpenStack related topics? Nope. You're low. Pretty close. 32 sessions. That's a good guess for the guy that comes in late. I know him, so I can give him a hard time. So, but if you want to get more in-depth about OpenStack or OpenStack 101, or maybe hands-on, you want to get some overview of the state of OpenStack, there's a lot of different OpenStack sessions that I believe relate to the topic we're going to be talking about. But we're here going to assume you know a little bit about OpenStack, what it does, why you want OpenStack. Mike's going to cover some of that. But ultimately, if you want to get more into the technical bits and bytes, the hands-on, the futures of SUSE OpenStack Cloud, here are the sessions you want to go to. And with that, I'd like to turn it over to Mike Cohen.
Thanks a lot, Mike.
Yep.
And as Mike mentioned, I think I'm going to start by giving you an introduction to our vision around SDN and also our products, our ACI product line, and then talk about how that works together with OpenStack and SUSE OpenStack Cloud. And then I'm going to hand it back to Mike, and that's where we're going to see some of the demos and and live stuff. I'm happy to take questions. I've worked on this material for a long time, so I'm happy to answer your questions on it. So feel free to throw them at me if you have any as well. So let me start by kind of laying out our vision around SDN, and it actually encompasses a number of different areas. And this was driven off trends we started seeing in the data center environment as we saw things like new endpoints developing with mobile access, with access patterns around cloud and public cloud, private cloud, and hybrid cloud, big data developing. It really added a huge amount of complexity to the data center. And when we thought about how we're designing the network, we actually wanted to develop better ways of managing that complexity, reducing that complexity, and making it easier to essentially provide a simplified environment, handle orchestration, standardize orchestration, make it faster to deploy new applications, offer options around automation, and really make it quick to deploy your new applications and your new workloads. And additionally, we didn't want to leave out this point of analytics. And this is actually something we baked in at some of the lower levels of our products to give you visibility into how the environment is working. This has become critical in environments like OpenStack, where you have conceptual separation, neutron networks, and you may have physical networks. And when something goes wrong, they affect your end users. Your end users don't necessarily know where the problem is. We need to be able to tie those things together and say, you have an L1 problem. Someone disconnected a cable, and that actually affects your end user, and we need to show you how to make that connection. And that's been part of our vision around these products from the very beginning. So there are a couple of products I'm going to talk about today. The primary one is Cisco ACI, our Application Centric Infrastructure, which is our SDN network fabric. I'm going to briefly touch also on Cisco Cloud Center, which is essentially our cloud automation suite that actually can sit above a platform like SUSE and OpenStack and actually drive it with different application templates. And then I'll also briefly touch on Tetration Analytics, which is an analytics product we have that can give you very deep visibility into how your applications are interacting within your data center environment. So let me start by just laying out the foundation for all our technology is on the networking side are our Nexus switches. And if and it's important taking a minute to talk about where we are with Nexus and how we're leading the market. So a number of months back, we released something called our Cloud Scale technology, which is essentially a new ASIC technology within our switches that actually gave us something on the order of a 2-year leap ahead of all our competitors that are using merchant silicon. In terms of much larger scale, in TCAMs, in route tables, enabled us to hit better cloud economics. Where we could actually do things like 25 gig down to the server, and 25 and 100 gig for the cost of what people were doing 10 and 40. So we're actually enabling you to make that technology leap just in our core platforms. And the last piece was enabling services. So again, built into the switches are the ability to give you this deep analytical capability to understand what's going on. And we tie that back ultimately to the OpenStack layers. And the primary focus of this talk is going to be on ACI. And ACI is our enterprise class SDN solution based around policy automation. But I wanted to highlight that our switches themselves were actually designed as very flexible components. So they are the building blocks through which we design and build ACI. But we also use them, and our customers use them in a number of different ways. We actually have other deployment models, and we have customers across them. So they include things like what we call a programmable network, which is a traditional network design, but fully API driven. So people are using the REST APIs we exposed on the boxes, but they're still designing traditional networks. And we have customers that are doing that today, and they're very happy. We also have what we call a programmable fabric, which is a VXLAN fabric, but using our EVPN control plane, and again our standard NXOS deployment. We have customers that have deployed that model. But where we're seeing a lot of our customers going is to ACI because it really offers the best of all worlds in terms of physical plus virtual integration and the full management that you need on top of that to make it useful to deploy applications quickly. So now let me start by introducing ACI. And our vision from ACI really started around this idea of application agility. We wanted to make it faster for you to deploy applications in your data center. We saw that being one of the driving factors of how people were going to improve ROI in their environments. But to do that, we actually started peeling back the onion, and we discovered a number of capabilities we had to add. The first thing we had to do was think about how to simplify and automate the environment. So if you looked at how people were modifying networks, historically, they'd go switch by switch. They would program a VLAN. They would have some change control process, and review before any change was made to deploy a new application. It made it very slow. So what we did here is we said, well, we're going to give you a whole managed fabric, and make it multi-tenant and allow you to use a higher level policy written in application terms to deploy your application across that network fabric and make sure it can't interfere with anyone else, in the process. So that abstraction layer became really important. Then we had centralized provisioning and visibility. We gave you a controller that would actually manage the entire environment. And you essentially push your configuration to our one controller. We'll manage your entire fabric. You can put your application anywhere. You can move it anywhere, and we don't care. And the last piece was automation and programmability. Really making all these capabilities accessible over an API. So you can go into a CLI and you can make these changes. You can go into our GUI and you can make the changes. You can make them directly from OpenStack, and that can push over a REST API to our controller. And we're agnostic about how you interact with the system. We give you a single point of management, a single point of provisioning across the entire environment. So that, essentially that's the foundation of the ACI product. And if you look at it, you'll see the key components on the left here. At the lowest layer are switches. So these are Nexus 9000 switches, which compose in a leaf spine topology. Our APIC controller, essentially this is an appliance that we distribute designed to manage that fabric. And then the policy model. So the policy model is an abstraction actually that we introduced as a way of defining how applications interact and allowing that to be programmed across the entire fabric. I'll talk more about that as I get going. So if we think about what we mean by policy here, I'll use an analogy to try to relate it for you. That we really looked at what network teams were doing, and network teams were thinking about VLANs and routes, and ACLs. And then we talked to application teams, and they were saying, well, I actually have, I need this port open on, on my server, and I'm going to connect to it, and I might need a load balancer in between these components, and someone's going to put a firewall out there, and that's fine. But very, very high level, application level SLAs, and there was this huge disconnect between these groups. And often, what happened was, these teams would, application teams would, give the requirements to the network team. They would manually dissect them, translate them into something lower level, program them on the switches. And we said, well, let's break down that process and actually allow the network automation suite to start taking things in the terms the application developers understand. We can change the network language. No longer would you have to provision a VLAN. We can actually allow you to provision a group that looks like a tier of web servers. And you can say that tier of web servers is going to access the app servers on these ports. Let's make that the input to the networking automation. And again, this was one of the critical components. And we designed a whole policy model meant to model how applications are really built, not how networks are built. So if I kind of peel back the onion a little bit more, just to give you an architectural picture of what this looks like in practice, is ACI was designed as a system that can manage both an underlay environment and have this policy-based overlay, essentially as a feature of it. So this is the critical piece that gives us this physical plus virtual integration. So if we look at it at a fabric layer, it's a leaf spine topology, all running VXLAN with a cluster of controllers attached to it. And that is a fully managed underlay environment, right? You hook it up, you plug it in, go in our controller, attach the switches, you're done. There's nothing to do in this underlay environment. It's fully managed for you. And then in the overlay, you would be able to define these policy constructs. A three-tier app may look something like this. I have your web app and database. They talk over these ports. These are the guys that need to get out on the web server side. Maybe I stick a load balancer in between here, and I'm done. Wherever I now place pieces of that application, the fabric will adjust and make sure the policy is honored. So we made essentially an overlay, but we made it as almost a feature of the fabric itself. And the cool thing about doing it this way is we can actually do this same capabilities across physical environments, across virtual environments, across multiple hypervisors. You'll see as we do stuff with VMware and Linux together, for example, in OpenStack. So critical components we see as part of ACI. One is this application-based automation with comprehensive security. the idea of being able to define policies, send them to the APIC controller, and have them deployed across the entire environment. We also include automated layer 4 through 7 stitching. So we can actually automate the insertion of the load balancer and even the deployment of policies on those load balancers and firewalls across the environment as well. So we're automating that last mile on the layer 4 through 7 side. And there's a number of ways this can be achieved in the OpenStack environment. And then the last piece is around this idea of turnkey network automation. So, today, even in OpenStack environments, a lot of energy is spent managing the underlay. And in this environment, that underlay basically becomes completely free. There's zero work to manage it. And that all, essentially, ACI takes care of that entire environment. All of that traditional network automation goes away. Another key aspect of ACI is this idea of visibility, being able to have an integrated overlay and underlay where we can give you telemetry across these environments, centralized APIs, centralized management from our APIC controller, and then health scores. So we're actually rolling up health scores for specific tenants and for specific application groups that you can map to specific neutron networks. If something goes wrong in a neutron network, we will tell you why, and we'll actually help you figure out, was that a problem that happened in the real physical network? Was it a problem that happened on the hypervisor, in the OVS, a misconfiguration issue? We can show you these things via our health scores. Now, I'm not going to belabor these the studies here. You can find them online, but we've had a number of customers have massive savings as they've deployed ACI, and a lot of that savings comes from the operational benefits of not having to manage the network anymore. They can now deploy their application as a REST API call. Directly to APIC. So there's been huge cost advantages that come from moving to this kind of architecture. I'll briefly introduce two other products that we have in our data center portfolio before I get onto the OpenStack piece. Cisco Cloud Center is actually designed as a hybrid cloud automation suite. Essentially, it allows you to define your application templates and deploy it to any cloud environment. Of course, one of those cloud environments can be a SUSE OpenStack Cloud running inside your data center. But Cloud Center plays very nicely with ACI and, again, was designed to help you solve this hybrid scenario. Another product that, again, could have its own hour session is Tetration Analytics. So Tetration was actually designed as a very deep, analytics product designed to help you understand the dependencies between your applications, understand how they're interacting, and essentially what requirements they actually have. This can be really useful to discovering how applications work in your existing environment, especially if you wanted to move them to ACI or audit some of your security requirements. So again, this product is has gotten a lot of attention in the market so far, and we've been really, really excited about it. So now let me get on to OpenStack. I want to make sure Mike has time for his demos as well, because no talk would be complete without them. So I'll talk for a second about ACI and OpenStack. And OpenStack has been one of our key areas of investment around ACI. And I've had a team in engineering focused on this for a number of years now to make sure that we have really strong integration. So we've built plugins for OpenStack, and I'll talk about the differences between them. But one essentially uses our policy model from ACI and something called group-based policy, and we also have a regular ML2-based deployment as well. Our solution actually leverages OVS, the upstream OVS that'll ship with SUSE. And then we use something called an OpFlex agent, which is an open source component that allows our fabric to also manage the OVS as if it's part of our underlying infrastructure. So we actually can extend our policy domain to even down to this vSwitch using these open source components that were created. And that actually lets us manage both a Linux environment based on KVM and a VMware environment together in the same OpenStack cloud. Different availability zones, but with unified networking across them. This is one of the big advantages we come with the ACI solution. The other thing you'll see that we can do, since we have the fabric and vSwitch control, we can also give you a fully distributed networking solution. So we take away all of the network node components that tend to be centralized, and we allow the fabric to take over them. So we can do distributed routing, distributed L2, distributed L3, distributed NAT. All comes as a result of this architecture that we've developed. We also give you a very easy way of tying in things like bare metal services, because we have gateway functions happening at our top of rack switches in our ACI fabric. And of course, all the ACI visibility pieces I was talking about are present here as well, and they can be tied back to the neutron networks that you create in OpenStack as well. Obviously, another critical piece we've been working with SUSE on is the SUSE integration, right? Having bar clamps to actually deploy OpenStack in a seamless way with the ACI plugins installed, as well. And obviously, we've been slowly adding integrations on the OpenStack side for different extensions, things like LBAS and allowed address pair, hierarchical port binding are all supported in our plugins today as well. I'll talk for a second about group-based policy. I think you'll see this in the demo. So group-based policy was actually a project we started to take some of the concepts we had in ACI around policy and changing how network is defined, and moving that as a full class, essentially a first-class citizen in OpenStack, allowing you to define policies around groups rather than around networks, and push them down to different Neutron plugins. Obviously, we enable that with ACI, but this project can actually work with any Neutron plugin that you choose as well. And it is one of the integrations we've done with SUSE that we have different customers deploying. A quick view of kind of where we're going here. One of the key directions for our team is actually taking our two plugins, our group-based plugin and our ML2 plugin, essentially merging them together, allowing you to use group-based policies for some tenants and standard security groups networks for other tenants, and actually have them interact in a seamless manner inside the OpenStack environment. Obviously, we're always working on on supporting the latest OpenStack releases. We support through Mitaka now. Our team is working on Newton. We've been doing a lot of work in NFV, as of late. Things like SRV, OVSD-PDK, the VPP, and have integrations in those areas. IPv6 has been a major push for our team. We've had customers, moving to IPv6 using dual stack environments. Ironic Neutron integration, which is just coming from the community, we're actually in a really strong position to enable that because we have our programmable gateways. And then also being able to do things like, what we call a copy service, which is an ACI capability where we can actually, seamlessly span packets out of different Neutron networks to different locations. So these are all things that we're looking at from a roadmap perspective. The one thing I'll go into a little more detail on is the unified plugin. We don't have a demo of this today. If you want to come talk to me, I can talk about it after. But basically the idea here is instead of today our group-based plugin is essentially a separate piece from our ML2 plugin, and they have to exist in different OpenStacks. And what we're doing is essentially merging them together and allowing you to create group-based policies that purely live on top of the Neutron constructs. And this was actually one of the key things that made this possible was the introduction of address scopes that came in Mitaka. So we can actually do a clean mapping between these things now. And this allows us to have different tenants coexisting using different models on the same fabric. Again, potentially with different hypervisors even at at the lower levels as well. And before I hand it off to Mike, I just wanted to quickly splash some numbers up for you. That we've had massive traction with these products, both our Nexus 9K and our ACI products. In a little over 2 years, we're over $2 billion in revenue, and we're growing really fast. So we've had great customer uptake. We've done a great job with SUSE. We have a number of joint customers that are in deployment now, using the solutions we were just talking about.
Mm-hmm. All right.
Yeah.
Awesome, Mike. Thank you. So now let's talk a little bit about SUSE OpenStack Cloud and the work that we've done together. But let me kind of take a step back, and Mike had mentioned the customers. And honestly, this started with one particular customer, an opportunity in South Africa. And this is a public customer, so I'm going to mention the name, Standard Bank of South Africa. They we're already committed to SUSE OpenStack Cloud. They're already a big SUSE customer in a number of areas. And they came to the local team and they were very interested in integrating or working with Cisco and SUSE to create the integrations. But they needed help. They needed help from Cisco because they had already purchased a lot of the ACI equipment. They had ACI in their data centers, but they also said, hey, SUSE, we need you to work with Cisco, make sure that we actually get these integrations in place. So I was tapped on the shoulder, and make a long story short, I tried to make it work, and I got it to work. But I had to touch a lot of different configuration files. I had to go and make a lot of different changes within the OpenStack configuration just to make it all fit and work together. And I said, there's got to be a better way to do this. So we took have I moved the, let's see. Yeah, we took what Cisco creates. Yep, okay, I'm getting all excited. I'm moving the screen. We took what Cisco created, which is completely open source, and we pumped that into our open build service. So we created SUSE-specific RPMs, and those SUSE-specific RPMs, but it's easier to say. Those SUSE-specific RPMs are based currently on Cisco's APIC version 1.3. So it's from May of 2016, that was the release. Well, they're actually up to 2.1 now, and I'll talk about that here in just a moment. But we created SUSE-specific RPMs. That makes it easy to get them installed. But we've gone even further, and I'll talk about that here in a minute. But one of the other important things that we had to do was, for the Cisco ACI integration work to happen, it needed a newer version of the Open vSwitch that Mike talked about. And at a minimum, it needed Open vSwitch 2.4.1. Well, we built and did all of our testing, initial testing with Open vSwitch 2.4.1. But ultimately, our SUSE engineering folks have said that 2.5x, 2.5.0, 2.5.1, I'm not sure what version they're going to land on exactly, is going to be the long-term service version of OVS. That's what LTS stands for. So we are, and we will be delivering OVS 2.5 as part of our solution that when customers want to integrate Cisco ACI with SUSE OpenStack Cloud. So that's the Cisco side of it house. We basically built the necessary RPMs. We made sure that the supported OVS version that was needed by the Cisco RPMs were there. But again, I said it was, once the RPMs were built, there was still a lot of manual steps to get this stuff configured. You had to touch multiple configuration files. In the neutron.com file, there were some agent OVS configuration files or some INI files and things like that. And I said, you know what? SUSE OpenStack Cloud has this really amazing deployment infrastructure through our admin server utilizing Crowbar. And so I went to our SUSE engineering folks and I said, would it be possible to create or enhance the Neutron bar clamp and the Nova bar clamp? So we use the Crowbar installation framework as part of our admin server to automate the deployment of a lot of these very complex pieces that have a lot of configuration files. And I asked them, would it be possible to expand the Neutron and the Nova bar clamps? And they said, absolutely, let's get some engineers on it. And actually it was just 2 engineers, one in particular, that worked on it. And you're going to get to see a demonstration of the work that that engineer did. But basically we took a multi-step manual configuration and helped automate that, making it very easy to deploy. There are still some manual steps involved, and we just didn't have enough time. We needed to make sure we met the goals of Standard Bank of South Africa and a timing to make sure that we won that deal, which we did. So we had to basically say there are some steps that we want to automate in the future, but for now there's some manual pieces that need to be done. You'll see that in the demonstration. Out of the box, we support KVM today, but you heard Mike talk about VMware support. We're working on that and we'll be testing that. We do also support the Neutron ML2, so that's the native OpenStack way of managing networks. You think in terms of of routers and VLANs and networking constructs, like Mike was talking about. But we also support group-based policy network, that policy-based way of defining networks. When you're talking to the application folks, instead of them thinking about, I need this router and this virtual switch and this and that from a networking perspective, they say, I want to connect my database server and my web servers and plumb the network. I don't care how it's done, just make it happen. That's group-based policy. We support that as well. And then working very closely with our documentation team to get this documentation within the SUSE OpenStack Cloud 6 documentation. And I haven't mentioned this to Mike, but I would like to actually have a link available on Cisco's site that links over to our SUSE OpenStack Cloud documentation. I hope that wasn't going to be, well, I don't want to put you on the spot, but I'm hoping we can make that work. Now, there are future plans. As you heard, VMware support. We don't have VMware support in today. We have to build some newer version of our PMs, and that's based on the Cisco packages version 2.1. And as you can see, it's released October 17th. So just not that long ago, they've released it. As of yesterday afternoon, I got the word that the packages have been built. I just haven't had time to go through and test it. But I'll test that out, and hopefully we actually have several customers interested in VMware integration, taking KVM and VMware, all managed by ACI. And that's the next thing. We'll be adding VMware hypervisor support. And then you heard today and yesterday we talked about SUSE OpenStack Cloud and the new version that was announced, SUSE OpenStack Cloud 7, based on Newton. When that releases, which will be around the end of this year or the early 2017, we're already in lockstep with Cisco to begin testing as soon as their Newton version of the ACI drivers are available. So I'm hoping by December timeframe we'll be able to start testing, which lines up perfectly to our release cycle for SUSE OpenStack Cloud 7. So before I jump into the demo, I'm thinking the demo is going to generate some questions, but are there any questions on anything that you've heard from either this mic or this mic? Does it make sense to everybody? This is cool software-defined networking. We've been talking a lot about software-defined networking, software-defined infrastructure. So let's see it in action. Hey, Mike, would you mind doing your magic and let's... so I have 10 minutes worth of video. This actually is quite an in-depth video because I wanted to show all of the pieces of it. So I created a quite extensive video. We can play all 10 minutes. We have plenty of time to do it. Is everybody okay with 10 minutes worth of video? We may stop along the way. Okay, you'll get to see the whole installation, the whole configuration, using the bar clamp, some of the manual steps I talked about. We're going to start with ML2. So we're thinking in networking constructs at this point. We're thinking in switches and virtual switches and routers and all those kind of things, VLANs and all that kind of stuff. Network, core on networking. The second video is going to focus on GBP and focus on the application developer saying, I've got a database server, I want to connect a web server to that database server, plumb the network. I don't care how it's done. Okay? All right, so let's go ahead and start. So here is SUSE OpenStack Cloud, our main dashboard. As you can see, if you want to pause it there for a second, Mike, we've got our admin server. We've got our control node. It's a very simple setup, but we needed to prove the technology, and we have 2 compute nodes. Okay, go ahead and move on. So now we're going to do some of the manual stuff that needs to be done ahead of time. So I'm going to go to the first compute node, and I have to actually configure the NIC that's connected to the ACI fabric. Again, this is stuff that we want to automate as well, but in today's setup, we had to do it. So as you see, I'm going to connect. I'm going to go to the particular NIC, which is ETH1 over on the right-hand, the third column, and I'm going to provision it. I'm going to create a VLAN signed 4093. This is all networking stuff that has to be done. I'm going to do some routing table information that's required by Cisco ACI for things to communicate properly. I do that I do that also on compute node 2. As you can see, I'm running OVS version 2.1, and it's creating these integration ports. And I'm also able to actually make sure my compute node is able to talk to the particular Cisco infrastructure. I know I can get down to the port within the switch. So now we're actually, if you want to pause it for just a second, Mike, thank you. We're now looking at, we've switched from SUSE and SUSE OpenStack Cloud and touching the servers that make up SUSE OpenStack Cloud. Now we're to the web interface of the APIC, and you may have seen that. This is the central management interface for the fabric. And so this is the thing that SUSE OpenStack Cloud talks with and sends the RESTful APIs to tell the Cisco ACI to provision the network. So we're gonna go ahead and start the video up again. And this is basically to show that within the APIC, there was an OpenStack, but nothing has been provisioned at this point. Now we're gonna go ahead and you can let it run. So there's no OpenStack defined within Cisco APIC at this point. We're going to go ahead and let the bar clamp run. We're going to go down to the Neutron bar clamp, which is the networking bar clamp for SUSE OpenStack Cloud. We're going to select APIC ML2, and we're going to say we want a VXLAN OpFlex configuration. I won't go into all those details, but we're basically going to make some additional changes that have to be made within the attributes. We didn't have time to put some of the things into the fields, so you just have to go in and you have to add some things about your APIC's ID information, some information about the APIC switches. And this is all stuff that comes from like the previous command you saw where I was trying to figure out what port I was plugged into. That stuff comes out of that. So once I make all of those changes, then we're going to go ahead and apply the Neutron. We jumped way ahead? Maybe back it up a little bit because it's if you don't mind. Hopefully, okay. Let's see here. So the Neutron has already been applied. Okay, yeah. Now and then we have to basically go into the Nova, and now we're basically saying we need to set up these two compute nodes as KVM compute nodes. You have to do these two steps. You have to deploy Neutron and Nova, and I do it very quickly because of video, because I don't want to waste a lot of time. It usually takes about a couple of minutes, but now you can see that OpenStack, where it didn't have anything, automatically has talked to the APIC. The APIC now knows about SUSE OpenStack Cloud version 6, knows about the compute nodes, and voila, the basic infrastructure is already in place for SUSE OpenStack Cloud now to talk to the APIC and drive it. We're going to go ahead and deploy the Horizon bar clamp, and now we're looking at Horizon. This is the dashboard that the users can go ahead and provision instances. We're going to go to networks, and at this point there are no networks defined. We're going to create a network. Now this is thinking about a network, a subnet, a VLAN, all those kind of things. So you have to give it specific networking details, like its network address, like 192.168.101.0 with a /24 subnet. And you have to make sure if you need it, and you have to put in all these networking things that drive people crazy. But when all is said and done, what has happened is SUSE OpenStack Cloud has now talked to the APIC, and the APIC has been configured with this particular network. And you can see over on the right-hand side, Net 101 right here. So it's actually tied to SUSE OpenStack Cloud and Net 101. Okay, so now we've got a network plumbed. Now let's start up some virtual machines. So we're going to go to our SUSE Linux Enterprise Server juice image, just enough operating system. I'm going to fill out, I want 2 of these instances started. And I'm going to tie it to Net 101, and I'm going to say launch. So I'm going to actually be launching one virtual machine on each compute node. And if everything works properly, the compute nodes should be able to communicate with each other. And they're running, and you can see that these are on the different compute nodes. I'm going to go ahead and go to the console of one of the instances that were started on the compute node. You can see now I can go ahead and log in as root, and I'm going to clear the screen. I received an IP address from the fabric, from the ACI fabric, 101.4. And that's it. Now I haven't pinged anything because I left that for the GBP. But trust me, these were pinging. But now I want to go ahead and let's make the jump. So this video was again focused on ML2, and that's the traditional OpenStack way of defining networks. Very network centric. So my university degree is in computer networking. So I understand switches and routers, maybe not as good as Mike here, but I understand it at this level. When I first was introduced to GBP, it was like, wow, that's really cool. It's taking the language of the application folks and allowing them to define things in their terms and let the fabric worry about configuring the networking. It can handle that. So let's go ahead and start this video. And as you can see, we have the same environment. Actually, it's currently running ML2. I'm going to go back and I'm going to change it. So because of the bar clamps, we can make the change on the fly from ML2 to GBP. So if a customer starts with ML2 and they want to go GBP, they can do that. I'm going to make a few changes, reapply the bar clamp. After a few minutes, it is done. I've already got my OpenStack environment running. Now you can see I've got this new item here. If you want to pause it there for a moment, Mike. We've got this policy. That wasn't there before. That's part of the GBP packages that Cisco has created and open sourced and made available to the OpenStack community. Now, instead of thinking in networking terms and going into network and then defining the network, now I'm going to go ahead and define groups, and I'm going to define policies around those groups. So go ahead and start that back up again. And we're going to start with policy actions, and we're going to create, and I go through this very quickly because there's a lot of clicking, but we basically create policy actions, create a policy classifier, create a policy rule. I create all those policies, and then I'm going to create two groups, a DB group and a web group. Okay, pause it there for a minute. Thank you. And basically, with the DB group is the provider. They're providing a service to the web servers. The web servers are consuming what the database is providing. Make sense? So that's what we're showing over here. The database group is providing access to the database. The web group is consuming what the database is providing. Okay? So let's go ahead and fire that up. So now we're going to go into the database group. And I'm going to say, let's create members. Let's create virtual machines. Let's create instances. But now I'm going to say, all right, I'm going to create a database instance. I'm going to create two of them. And I'm going to select my juice image again. I don't worry about group, but I'm going to go now. You can see it's not network associated, it's group associated. It's associated to the DB group. It goes off and launches the two members, okay? And we'll show you what that means here in just a moment. Now I'm going to go back and I am going to create the web group. I'm going to create two web systems I did it, I jumped ahead because I didn't want to take the time because I had already shown you how to do that. If you want to pause it here, now I actually have two database servers. In essence, I have two instances that are part of the DB group. I have two instances that are part of the web group. You can see that I defined no networking information. I didn't define 192, 168, something. The ACI infrastructure did that. The group-based policy packages took care of all of that for me. So the database group is on 192.168.0. The web group is on 192.168.1. And if my policies are all correct, my web servers ought to be able to ping my database servers. They ought to be able to ping themselves, and they ought to be able to ping the database servers. This is a very simple example. So go ahead and start it back up, Mike. And I just wanted to show the networkings that were automatically created, the networks that were automatically created. Now we're going to go to the instances. We're going to go to Web 1. We're going to go to the console of Web 1. I've already logged into it just to speed up the demo. Check the IP address. It's the proper IP address. Can it ping its sister web server? Yes, it can. Because it's in, I know it's a sister web server because of the 1. Now we're going to try and ping a database server. Can I ping a database server? 0. I don't know. Let's see what I'm going to go back and I'm going to look. The database server I'm going to ping is 0.4. Yep. And that happens to be the database server that's on the same compute node. Now I'm going to go ahead and ping 0.3, which is actually traversing the ACI physical fabric. Now, we know the communication's all working. I'm going to go ahead and very simply disable one of the policies. I'm going to basically disable the consumer policy, and now you can see the pings have stopped. They're not moving anymore. So by just taking that policy and saying, I don't want that policy to exist anymore, it stopped. I'm going to go ahead and re-add the policy back so that the web servers can talk to the database servers, and voila, you can see the pinging starting to happen again. And that is the end of the video. That's the end of the demo. So I tried to speed through it very quickly, but hopefully you have the, hopefully you saw ML2, OpenStack ML2. You think in networking terms, you think in VLANs, you think in IP addresses and everything like that. In GBP, you're the application person. You care about database servers, you care about web servers, and just let all that other networking stuff happen I don't care about. So hopefully you saw both of those and how we, SUSE, through our SUSE OpenStack Cloud, have made it very easy to deploy it, and how we've worked very closely with Cisco. And I have to, before I open up to questions, I have to thank Mike and especially his marketing, technical marketing engineer, Ifti. Ifti couldn't make it, but Ifti and Mike have been very gracious. Cisco's been very gracious to provide access to an ACI lab. So if any of you are interested in seeing a little bit more or talking to Mike or I a little bit more, I can VPN into the Cisco lab. At this point, I'm in the midst of trying out the OVS 2.5 components, so it's kind of in a weird state.
I have a lab.
But okay, you have a lab? Okay, look at that. Mike even has a lab, so this is awesome. But with that, one, I'd like to open it up to any questions that people have. Anything that was confusing, I'd love to clear it up for you. So, yes?
Well, the first thing that you are mentioning is that today this demo was with the OVS 4. We are expecting to have this in a stable with OVS 5. So today is particular with OVS 4.
Yes, so today the demos that you see here are with OVS 2.4.1. No, that's fine. The numbers, we've thrown a lot of numbers at you. If you have a customer, or if you're a customer and you're interested in getting this, today I will provide you what we have working with OVS 2.4.1. But we're having one minor issue with OVS 2.5 that we're working on. It's something on my side. I did something wrong.
The upstream stuff Cisco provides, I think, works through OVS 2.6. but there's packaging. Obviously, when we work with, like, there's packaging issues that we're resolving.
It's a packaging.
If you really needed 2.5, like the upstream stuff we have, you could even get, because it works with 2.5.
Yeah, and so it's just a minor little thing we have to work out. But if you wanted to start working with your customers, or if you're a customer and you wanted to start testing this in your lab, which I absolutely would love you to do, let me know. We'll get you the necessary pieces of the packages, the bar clamp, the graphical interface of the bar clamp, and then and the OVS pieces as well, and you can try it out. We have documentation written. We're working on formalizing the documentation, but it's all. But once we get the 2.5 issue resolved, which is again my problem, which I hope to resolve this week, then we'll be using 2.5. Yes. Good question. Thank you. Okay. Well, are there any other questions? Anything? Yes?
As a whole, as a solution, we're talking about that some customers are looking for white boxes. In particular, also for the networking, we have white boxes. This kind of solution, the Cisco ACI works in those type of...
No, so Cisco ACI is a fabric solution, right? So it works with switches from Cisco. In particular, it works with an XS9Ks. So it's not compatible. You cannot bring your own switches and make them ACI. You actually have to use the switches that are designed for it, right? Which are the 9Ks that we sell.
But the white boxes, are you meaning the compute nodes?
From a server perspective, we're completely agnostic. You don't have to use our UCS servers. You can bring any server you want. The switches themselves have to be Cisco.
Right. Yep. So with one customer that we're working with, it's all Cisco ACI, Cisco UCS. With another Cisco customer, it's Cisco ACI with, I believe, Dell hardware. Although they did some testing with the UCS hardware as well. So we've tried multiple different combinations. We've validated both UCS C and also B series systems, so the blades and also the chassis mounted UCS systems.
We're agnostic about servers with this solution. Everything we said here would apply with any server that you choose.
Right. Yep.
Obviously, it would need to be qualified for SUSE Linux and all these, these kinds of standard things, right?
Yeah, yeah.
But otherwise, we don't. Cisco side, we don't have. ACI doesn't have any specific server requirement.
Right. Yep. And we've tested it with both 10 gig NICs on the fabric and also 1 gig NICs on the fabric. So we've tried multiple different.
And we'll do 25 gig NICs now.
And we'll do 25 gig NICs. We have not tried that. That'd be cool.
Very few have this. It's harder to get 25 gig NICs.
Yeah. So, great questions. All right. Well, with that, again, 5 minutes back, hopefully this was a good session. Lived up to my expectations that I would do well, and we would have a good session for you. If you have any questions, come by the Cisco booth. You can look at these videos again. You can dissect them a little bit more. We can talk about it in more detail. Mike is here the remainder of the day and part of tomorrow. I'm here the remainder of the week. But we'd love to hear your interest in taking advantage of the combined effort that we've done over the last year. Thank you very much.